When considering replacing a neutral bus with a ground bar, there are several potential red flags to consider. Firstly, ground fault protection. Some circuits require fault protection on the neutral conductor. Substituting a ground bar for a neutral bus may not provide the necessary level of protection. Secondly, high demand on the neutral. If the neutral conductors experience high demand, substituting a smaller neutral bus with fewer lugs may not be sufficient. Thirdly, panel limitations. The existing panel may not be designed to accommodate a larger ground bar or may require modifications to fit. Fourthly, code violations. Replacing a neutral bus with a ground bar may not comply with local electrical codes. It is recommended to consult a licensed electrician. They can assess the current load, panel capabilities, and code requirements to determine if substituting the neutral bus with a ground bar is feasible. Another consideration is to consider a larger panel. If the neutral bus is at capacity, it may be necessary to upgrade to a larger panel with more space for both neutrals and grounds. Furthermore, install a subpanel. Adding a subpanel in the garage can provide additional space for neutral and ground conductors. It is also an option to split the neutral conductors. This involves separating the neutrals from different circuits and connecting them to individual lugs on the neutral bus. It may not be possible in all cases. Safety considerations are also important. Ensure that all conductors are properly secured and insulated. Ground the new bar or bus securely to the panel enclosure. Verify that all circuits are functioning properly after any modifications. Always refer to the manufacturer's specifications and local electrical codes before making any modifications to an electrical panel. When dealing with electrical panels, understanding the role of the neutral bus and the ground bar is crucial for safety and code compliance. The neutral bus is responsible for carrying the return current from electrical circuits back to the source, typically the utility transformer. It is connected to the neutral point of the power supply and provides a low impedance path for the current to flow. The ground bar, on the other hand, is connected to the grounding system, which is designed to provide a safe path for fault currents to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Replacing a neutral bus with a ground bar can have several implications. Firstly, the neutral bus is typically insulated from the panel enclosure, while the ground bar is bonded to the enclosure. This difference in insulation can affect the way fault currents flow and may compromise the ground fault protection of certain circuits. Secondly, a neutral bus is sized to carry the maximum neutral current expected in the panel, while the ground bar is sized to handle fault currents. Substituting a ground bar with a smaller capacity than the neutral bus can overload the grounding system and create a safety hazard. Thirdly, electrical codes often require specific wiring configurations for neutral and ground conductors, and replacing a neutral bus with a ground bar may violate these codes. For example, the National Electrical Code, or NEC, specifies that the neutral conductor must be insulated and identified by a white or grey color, while the ground conductor must be bare or have green insulation. Mixing up these conductors can create confusion and increase the risk of electrical shock. When evaluating the feasibility of replacing a neutral bus with a ground bar, it is essential to consider the type of circuit served by the panel. Some circuits, such as those supplying sensitive electronic equipment, may require a dedicated neutral conductor with low impedance to ground. Substituting a ground bar with higher impedance can cause voltage fluctuations and disrupt the operation of these circuits. Other circuits, such as those supplying ground fault circuit interrupters, or GFCIs, rely on a specific wiring configuration to detect ground faults. Replacing a neutral bus with a ground bar can interfere with the operation of GFCIs and compromise their ability to protect against electrical shock. In addition to consulting a licensed electrician, it is also advisable to contact the local electrical inspector to obtain guidance on code requirements and best practices. The electrical inspector can review the proposed modifications and ensure that they comply with all applicable regulations. Obtaining approval from the electrical inspector before making any changes can help avoid costly rework and ensure the safety of the electrical system. Upgrading to a larger panel or installing a subpanel can provide several benefits. Firstly, it can create more space for neutral and ground conductors, reducing the risk of overcrowding and improving the reliability of the electrical system. Secondly, it can provide additional circuit breakers or fuses, allowing for the installation of new circuits without overloading the existing panel. Thirdly, it can improve the overall safety of the electrical system by providing better ground fault protection and reducing the risk of electrical shock. When selecting a new panel or subpanel, it is important to choose one that is appropriately sized for the expected load. The panel should have enough capacity to handle the existing load plus any anticipated future load. It is also important to choose a panel that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or OL, to ensure that it meets safety standard. When installing a new panel or subpanel, it is essential to follow the manufacturer's instructions and all applicable electrical codes. The panel should be mounted securely to a wall or other suitable support, and all wiring connections should be made properly. The panel should also be properly grounded to ensure that fault currents can flow safely back to the source. Splitting the neutral conductors involves separating the neutrals from different circuits and connecting them to individual lugs in the neutral bus. This can help reduce the load on the neutral bus and prevent overloading. However, it is important to ensure that the neutral conductors are properly sized and insulated, and that all connections are made properly. It is also important to label the neutral conductors clearly to avoid confusion. Safety considerations are paramount when working with electrical panels. Before making any modifications, it is essential to disconnect the power to the panel and verify that it is de-energized using a voltage tester. It is also important to wear appropriate personal protective equipment, such as safety glasses and gloves, to protect against electrical shock and other hazards. All conductors should be properly secured and insulated to prevent accidental contact. Grounding the new bar or bus securely to the panel enclosure is crucial for safety. The grounding conductor should be sized according to the electrical code and connected to a grounding electrode, such as a ground rod or water pipe. The grounding connection should be tight and corrosion resistant to ensure a reliable ground path. Verifying that all circuits are functioning properly after any modifications is essential. This can be done using a multimeter or other testing equipment. The voltage and current should be measured at various points in the circuit to ensure that they are within acceptable limits. The circuit breaker or fuse should also be tested to ensure that it trips properly in the event of a fault. Replacing a neutral bus with a ground bar is a complex task that should only be performed by a qualified electrician. There are several potential red flags to consider, and it is important to consult with a professional to ensure that the modifications are safe and code compliant. Always refer to the manufacturer's specifications and local electrical codes before making any modifications to an electrical panel. For example, National Electrical Code, or NEC, Section 250.24. C specifies the requirements for grounding the neutral conductor at the service equipment. This section requires that the neutral conductor be connected to a grounding electrode system, which consists of one or more grounding electrodes, such as a ground rod, ground plate, or metal underground water pipe. The grounding electrode system must be sized according to the size of the service entrance conductors. NEC Section 250.28 specifies the requirements for bonding the neutral conductor to the equipment grounding conductor at the service equipment. This section requires that the neutral conductor be bonded to the equipment grounding conductor using a bonding jumper. The bonding jumper must be sized according to the size of the service entrance conductors. NEC Section 310.15 specifies the requirements for ampacity of conductors. This section provides tables that list the allowable ampacity of conductors based on their size, insulation type, and ambient temperature. The ampacity of the conductors must be sufficient to carry the load current without overheating. NEC Section 408.41 specifies the requirements for neutral buses. This section requires that neutral buses be insulated from the panel enclosure and that they be sized to carry the maximum neutral current expected in the panel. The neutral bus must also be identified by a white or grey color. These are examples of the types of code requirements that must be considered when replacing a neutral bus with a ground bar. It is important to consult with a qualified electrician to ensure that all applicable code requirements are met. Additionally, consider the load calculations. It's crucial to perform load calculations to ensure that the existing panel and the proposed modifications can handle the electrical demand. This involves determining the total amperage required by all the circuits connected to the panel. The load calculation should take into account both continuous loads, which operate for 3 I/Os or more, and non-continuous loads, which operate for less than 3 I/Os. Continuous load should be multiplied by 125% to account for the additional stress they place on the electrical system. After performing the load calculation, it's important to compare the result to the capacity of the panel. The panel's capacity is typically indicated on a label inside the panel door. If the load calculation exceeds the panel's capacity, it may be necessary to upgrade to a larger panel or reduce the electrical demand. Remember to consider voltage drop. Voltage drop refers to the decrease in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause appliances and equipment to operate inefficiently or even malfunction. Voltage drop is affected by several factors, including the length of the conductor, the size of the conductor, and the amount of current flowing through the conductor. To minimize voltage drop, it's important to use conductors that are appropriately sized for the load. The NEC provides tables that list the recommended conductor sizes for various loads and distances. It's also important to keep the length of the conductors as short as possible and to avoid overloading circuits. If voltage drop is a concern, it may be necessary to increase the size of the conductors or install a voltage regulator. Ensure proper grounding. Proper grounding is essential for electrical safety. The grounding system provides a path for fault currents to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The grounding system should be installed in accordance with the NEC and should be regularly inspected to ensure that it is functioning properly. The grounding system consists of several components, including the grounding electrode, the grounding electrode conductor, and the equipment grounding conductor. The grounding electrode is a metal rod, pipe, or plate that is buried in the ground. The grounding electrode conductor connects the grounding electrode to the service equipment. The equipment grounding conductor connects the metal parts of electrical equipment to the grounding system. It's crucial to remember that when dealing with electrical systems, safety is paramount.